Hello and welcome to this GigaOM Research webinar sponsored by Vello Systems. Real-time infrastructure analytics meets SDN, the promise and challenges. My name is Paul Miller and I shall be your moderator today. Before I introduce our panel, let me tell you a little about the webinar console we're going to be using. Alongside the main window showing today's agenda, you should see an area in which you can submit questions to our panel. These questions are important and we invite you to submit them throughout the webinar. There will be time at the end of the webinar to address as many of these questions as possible. We may also address some of them as we go along. I should also apologize at this stage for the mouse pointer that you will occasionally see wandering around your screen. For some reason, you can see my mouse moving as I check for your questions, queue up polls, and generally manage the webinar. I will try to keep it to a minimum. Now, let me introduce today's panel and invite them to tell you a little about themselves. As I said, my name is Paul Miller and I'm the moderator of today's conversation. First of our panelists, Mark Leary. Hello, Mark.
Hi, Paul. Mark Leary, analyst, cover SDN and NFV and other intelligent networking technologies.
Wonderful. Thank you, Mark. And next up, Lee Doyle. Hello, Lee.
Hi, how are you? Lee Doyle. I'm principal analyst at Doyle Research, focusing on the evolution of intelligent networks.
Wonderful. Thank you, Lee. And last but not least, Par Boats from our sponsor, Vello Systems. Hello, Par.
Hello, Paul. Thank you so much. I'm Par Boats, and I spend most of my day trying to make networks more intelligent and work in a more automated way with applications and infrastructure.
Sounds like a good job. Thank you, Par. And now I'm going to pass back to you, Par, as our sponsor, to say a little bit about Vello and your perspective on the space before we get into the webinar. So, Par, back to you.
Sure. Would you mind forwarding to the next slide? And I'll just give you a brief overview of our company. We are a small company who started in 2009, and we are self-funded and majority employee-owned. And our mission is really to transform networks into application-driven compute environments, somewhat resembling the slogan of the 90s. We believe the network truly is the system, and if we can interconnect and operate that in the best possible way with applications, that we do some wonderful things for data centers of the future. We're 75 people. The vast majority of them are in engineering R&D. We have a couple of strategic partners, well-known names in the data center space, EMC, Splunk, VMware. We have quite a bit of customers. These are some of the larger customers that use us, and we are working really hard on just adding more things to that list and more technologies and capabilities to our product. And so with that, if you move forward, let me talk a little bit about our product and kind of what we do. So what we have built, and this is somewhat of a busy slide, is we built what you see in the middle, what we call the Vello network operating system. And what Vello allows us to do, it allows us to work with multiple hardware platforms, virtual networks, optical networks, Ethernet networks, as well as higher up in the stack. We built advanced applications as well as ecosystem applications that interact with proper business processes, infrastructure components, as well as real high-end end-user applications. We ship them in many ways, and I think that's important because I think that sets us apart from many others. Although what we really work on is what we call Vellos, and within Vellos we have something called the extensible abstraction plane, which allows us to span multiple technologies. We can run on top of Ethernet, we can run on top of optical, we can even run on things like LT radios for cell phones. We're somewhat technology agnostic, and what we do is we ship a Vello-powered box, so that people who wish to have one company quality for support and spare part and software, they can obtain that through us. We have partners who basically build systems using their own boxes, where Vello is the operating system that kind of runs on top of it. We have OEMs who OEM our system, and then you won't exactly know that it's Vellos, but it is Vellos that kind of powers their boxes. as well as we let customers, if they have the ability to select hardware from the ecosystem of what popularly called white box or gray box, or what we like to refer to as the customer's right box. If they do that, we support that too. Our main focus is really in building applications and capabilities for interacting with these devices. First, as a set of base functions in the Vellos, and then we have a series of more advanced services, which we call the advanced applications, that sits on top of the Vellos that builds more complex things like, policies and priorities and topologies and calendaring, and that then in its turn speaks to even higher order functions like Splunk and EMC disk products and VMware infrastructure, and even things like currency exchanges. And one of our customers even have built an application that allows the system to interact with one of the supercomputers and make it behave differently because of how our network interacts with it. So, we're pretty different, we're very flexible, and we have multiple ways by which customers tend to engage with us.
Okay, good. Thank you very much, Par. Right, let's get into the meat of the conversation now. And I wanted to start off with some definitions and some level setting. So what I'm about to do is put the first of our poll questions on the screen for you in the audience to answer. And while you're answering that question, I'm going to start off the conversation with the analysts to explore some of these definitions. So that poll question is coming up for you now. You should be seeing it on your screen. Now, Lee, I'm going to come to you first. Software-defined networking seems to be one of those things that's definitely flavor of the moment. Everyone's talking about it. Everyone's trying to work out where the opportunity might be. But from a business perspective, if you're a customer who has a network, presumably running on physical hardware at the moment, is there real demonstrable business value in switching to software-defined networking, or is it just another way to solve the same problem?
Right. I mean, software-defined networking is a challenging market and challenging market to define, but I think there is real value in today's products. It does make the network easier to provision, especially in the data center, and does start to deliver some real benefits today.
Okay, and Mark, what would your perspective be? Is there demonstrable, tangible value in pursuing an SDN strategy?
Yeah, undoubtedly. It's more than just the flavor of the month. It's kind of a next step if you really think about it in terms of networking. We spent the 90s on connectivity, and in the 2000s, as video came along, we spent a lot of time on speeds and feeds and such. It's about time we kind of refocused on management, and quite frankly, we've gotten away. We have the same kind of management tools that we've had forever in terms of CLI and scripting and all these things. So SDN's level of automation, the kind of control, the simplicity that it brings to networking is a significant step up in using our resources more efficiently, relieving the burden on the staff on a minute-to-minute operational standpoint, allow them to do a lot more of the planning ahead of time, and quite frankly, the making networks better instead of just keeping them running. So SDN has some real tangible benefits to them across a number of fronts, but it's too good to ignore, quite frankly, and that's why you're seeing a lot of suppliers going in that direction, but also new suppliers, people who traditionally haven't been involved in networking, and certainly a lot of startup activity as well.
And just taking a look at these poll results, and coming back to you for a moment, Lee, it would appear we are still at quite an early stage. Certainly amongst the audience on this webinar, about half of them are still at the stage of working out exactly how this might meet their requirements.
Right. Well, there's a GigaOM Pro report that I worked on that indicated that quite a number of folks are in very early stages of understanding SDN. So if you survey a broader population, you get the same answer, which is it's certainly early days, and people are trying to define and understand what SDN means to them.
Okay, that makes sense. Good. Thank you all for your poll responses. So continuing with the conversation then, and coming to you, Par, from a networking perspective, what's actually different about software-defined networking. Surely bits just travel from A to B regardless of whether it's software or hardware that's routing them.
It's a really, really good point. So thank you for asking that. And I kind of like that as a headline. Yes, you know, bits fly from point A to point B, and this is also the part of the problem as far as the network is concerned. Generally, he doesn't know that it's anything but bits. If these are particularly important bits, or if the bits that needs any different behavior, if they need to get to its destination in a high-speed lane via a jet plane, or if it needs to get to its destination on a container because it's a very large amount of bits, the network generally doesn't know that. It just tries to do whatever it can do. What we have the ability to do is if the network, and by the network I really mean if the applications are changing and they behave in ways that aren't all that predictable, if they have dynamically needs that needs to be more or less, then with technologies like software-defined networking, we can actually tell the network what has changed, how it should behave in response to that change, or if we have scarcity of resources, which is the resource that should get a better service. We can also do things like if we have multiple ways of transmitting these bits, we can select the way that's the most optimal for its use. Because also because of the very nature of how SDN works, if things change, if an event takes place, if a link goes down, if a communication path alters, SDN, at least the way we've implemented it, is aware of these resource graphs and remakes its decisions for how these, let's call them virtual circuits, or what we call flows, how they should be formed, and how they should be formed more holistically. We think that's actually really, really different than just about bits going from point A to point B. Sure, it won't solve the companies whose environments never ever change. It won't solve the companies who have over-provision, have more resources in the network than they ever need from the applications. But for everyone else, we can actually use these resources both more intelligently, more efficiently, and more cost-effectively.
Okay, good. And Mark, coming back to you, how do you get started? How would someone in the audience get started? Do you transform a small piece of your network and run it through using software-defined networking instead of whatever you were doing before, or do you actually have to rip everything out and start again?
Yeah, good question. Obviously, it's a leading question because if I said the second, SDN would never happen. Obviously, it's good to focus in on particular pain points. Yesterday, I was at Interop and sat in on a workshop, and they had a customer panel, some of the early users of SDN up there, and that was their first watchword, was focusing in on certain particular pain points where not only it allows you to focus in, but also allows you to draw your resources to bear on a particular problem. And also, quite frankly, the return is immediate that way as well. And you can't be moving towards SDN in kind of this step-by-step fashion and then hopefully in 2 years see some reward from it. It's just not acceptable in today's age. So you have to, again, focus on particular pain points, focus your resources on those pain points, whether that's investment in software and staffing, maybe new hardware or something like that. But again, you're trying to minimize and yet weave into the existing, and then also trying to grab the return as quickly as possible.
Okay, and Lee, coming to you with sort of an extension of the same question, where are those obvious pain points that Mark was talking about where you're going to see a quick win?
Right, so the obvious pain points are in provisioning new services, keeping up with rapid demands for data center networking in a private and public cloud world, new security threats, challenges of having you have a static hardware network, but you want to have a dynamic overall network, and that's got to be more software defined to accomplish that goal.
So, hey, thank you so much for making that point this far. And I just want to add something to that, because I think you make such a fantastic point. This has been our experience as well. Having a very clear and defined use for, or what I should say, problem within the business, within the data center that this technology can solve is the place where the biggest successes are. Because we span both the Ethernet world as well as the optical world, we found that attaching and solving problems at the edge of resources that are very, very expensive, particularly the data center to data center communication links, as well as sort of the data center to the client links. Those are the places where we tend to have really, really quick wins where we can do selective sort of bandwidth versus latency versus application in a very, very automated way. And so I fully support, pick your entry point and pick it based on where SDN can maximize its value, and that's how you really get to learn what SDN can do.
Okay, good. So dip your toe in the water and get going. Now, we don't want to just talk about SDN in its generic sense in this webinar. What we are interested in doing is looking at the match between SDN, which has been discussed in other places as well, and its integration with infrastructure analytics and some of the ways that begins to add value. So let's move on from basic SDN and begin to take a look at the analytics side of things. And Lee, I'm going to come to you first. Legacy networks, the hardware-based networks that everyone is used to and knows and loves, they very much rely upon monitoring the way the network's behaving, monitoring the way the network's performing, and then looking retrospectively at the logs and perhaps working out whether or not there's something you could have done better. Does that remain true, as you move into an SDN world? Is it still going to be retrospective?
Right. Management has been very much a looking backwards, looking at what the problem was as opposed to fixing the problem. The promise is to be much more proactive and to have software looking at the network in real time and dynamically change the network to the current conditions, whether that's congestion or security challenges or what have you. That's still a ways off, but software-defined networking tools do allow for much more proactive management, to be more agile, and there's some very interesting technologies coming down the pike on that.
And Mark, sort of extending the same question to you, is this a big area of activity and a big area of interest for the SDN community? Trying to understand the ways in which analytics can better shape the network?
Yeah, undoubtedly there is a lot of activity coming from a lot of different fronts, quite frankly, not only the traditional network suppliers, but a lot of new software entrants, a lot of new management entrants that are coming towards networking. People are seeing, and quite frankly, from the computing side of the fence, is bringing computing and networking together. That analytics is a good view of that, where you're seeing a tremendous amount of effort being put into analytics on the big data side of the fence. And a lot of those same principles, quite frankly, apply to networking. Par used the example before of the high-speed lane. Think of our highway network system, if you would, and think of you have to get from point A to point B, and the cars are just the bits. And our highway networking system would say, well, you get off on your side road, you get on your secondary road, you take your highway as far as you can, and then do the reverse to your destination. Well, think of how sensible, how nonsensical that is if you don't take into account time of day and traffic loads and what kind of car you're driving, how reliable it is, whether you're a new driver or not, and you're comfortable on highway speeds. Lord knows my daughter who's just learning, I wouldn't want her to go on the highway to get anywhere to point B. So from that perspective, understanding the environment, really without understanding what's going on, in a real-time basis, it's very hard to really have SDN deliver on its promise of automation and simplicity and improved utilization, because you don't, quite frankly, with all this, you can have all the control in the world, but without visibility, control is really hampered.
And in terms of that visibility, coming back to you, Lee, what are people recording? What are people tending to record? Presumably there's easy stuff like the raw load on the network and whether or not your pipe's congested or not. Is it typically more nuanced than that, or is that the sort of level that people tend to work at?
I think there's a very broad spectrum of how people manage and monitor their network. Some manage at a very high level, and others at a much more granular. There's different advantages and disadvantages to each. At a high level, it's easier to sort of see what's going on, and you're not drowned in data. if you're more granular, you get more detail, but then you have a big data problem because most networks have gigabits, 10 gigabits of data coming at you per second, and there's a lot to look at, and the problem today is you really don't know what you're looking for.
Power, is that what you're seeing as well? That presumably that's why people are turning to companies like yours, because they don't know what to look for themselves.
Well, I think when things are not changing and they're not super big, even if they're big but they're not changed a lot, you can partition the problem, you can understand the problem, you can do something about it, you can set up, certainly in the networking space, you can set up approaches to this. When things become fluid, and when you have competing priorities, and certainly when you have layers of infrastructure above you all the way up until the end user and application, and they changes how they want to interact with the system without doing that in coordination. You really only have two strategies. The first strategy is you can make sure you have more resources than you ever think anyone will ever consume, or the other strategy is you try to be very proactive in kind of right-sizing it. What analytics has shown us is, and this I think is an important point, is they can run through 1,000 observations in real time, millions of observations. They can then vary the input to each one of these observations to create all these what-if scenarios. And then they can, based on these what-if scenarios, predict outcomes with a certain amount of confidence. And they learn as they go on. They get richer and richer and richer. Or as our friend Splunk said, just listen to your data and it will steer you towards where you will end up. If we sort of use analytics, and use analytics particularly with IT resources as a way to make them self-correcting, or for anyone who's sort of graduated from electronic engineering, to have a feedback loop that allows the system to stabilize based on feedback and do so automated, then we can build some truly amazing systems. Clearly, we're just in the beginning of this, but analytics, I think, is going to revolutionize a lot more things than what people have seen to date, and I think it's going to be embedded inside of infrastructure itself.
And I think the point you were making there about shaping the network leads on very nicely to our next point. I think you've mentioned this a few times actually in the conversation already. This idea that the requirements on the network change, the amount of traffic flowing through the network changes, and that it's therefore important to be able to adapt to that and to respond to changing flows and changing demands, which leads us on very nicely to our next topic. This sort of fusion of SDN with analytics and being able to monitor and proactively respond to changes in the network. It really does, as sort of the last slide was suggesting, it relies upon rules and policies that tell the network how to respond in response to what the analytics are telling it. What do those rules and policies begin to look like, Par? And again, you did mention that a lot of this is at an early stage, but what sorts of things can you begin to build into a system to react and respond to this changing demand?
Sure. I mean, I can tell you what we have begun doing, and I mean, we worked with a couple of companies. I mean, I think the most well-known one that we announced yesterday is Splunk, and we've built applications within our application platform that allows Splunk to receive data from the network about things like topology and latencies and communication paths and applications. Of course, this is then gathered with everything else Splunk has done, and in real time allows Splunk to generate reports and other things about how things are. Now, that's useful for a user. I mean, humans are good at doing inferences based on patterns, and computers are really, really good at sorting and counting and creating patterns. What we're working on sort of next is, and this is what we've started to show some of our early adopters, is we also have the mechanism of letting Splunk speak back to the network and tell the network what is the behavior it desires to have based on other things going on in the network. This is what we think is really, really cool. Historically, analytics has been limited to really not being in real time, particularly on the infrastructure. it's been taps and ports, and we fed it to some reporting system. Worst case Excel, best case some kind of database or maybe shrink wrap software. And now with this more holistic approaches, we offer a new way and a new way to create those feedback loops. And that is really, really what's emerging. And that's where SDN really starts shining. It's just one of the many applications that SDN is capable of doing. If you couple that together with new types of systems architecture, from client-server to the scale-out space-based architecture, where north-south traffic is also meshed with east-west traffic, and where we're starting to have metadata that is serialized and needs to have in the high-speed lane versus data that's user-oriented and needs to be in the high-bandwidth lane, then we can start making some really, really interesting choices. This is what's happening right now. This is kind of what's being really, really exciting in our industry and certainly for our company.
And Mark, coming back to you, exploring that a little further. What are the sorts of things in reality that the network is able to report about itself? What sort of data are these systems going to be routinely seeing?
I think the most important thing you can kind of draw an equation to SDN here as well in terms of one of the greatest moves within SDN is this whole idea of top-down orchestration. You have centralized control. You're able to abstract the network and hide a lot of the gory details of how the network is operating, and obviously bring, as Lee mentioned before, dynamics. You bring on-demand reconfiguration, programmability, however you want to describe it. So all those things require information in real time on how the network needs to be made more fluid and dynamic. You can't just adjust the dam in the morning during a big rainstorm and then hope that survives until the next morning when I come back and maybe readjust it. It has to be, the level of water has to be monitored on a much more continued basis. So there you're looking from the base level at bandwidth utilization and how applications are using bandwidth, and at the highest level, obviously, end user response times. We don't take a lot of, there's a lot of systems that are using the network, and just about every application obviously is network dependent, and yet there's not a lot of consideration of the end user in most network management systems. We look at uptime and bandwidth and certain other things and say, oh, the network is fine, and then we just hand it off from there. So there's a lot more incorporation as networking and computing are coming together, and SDN is forcing that, quite frankly. There's a lot more consideration for that end user, what they're seeing, what their application is seeing, and because they are, let's face it, the judgment of the overall quality of the system. And to a great extent, that's where cloud providers are focused in on, as well as people that are looking at private clouds and trying to examine, how do you judge the quality of my system? And the end user judgment is the ultimate the ultimate criteria there.
Hey Mark, this is Park, and I think you're making such a great point. And I think it's useful to speak in analogs and sort of contrast that with something people know. Ultimately, it's about efficient usage of resource, right? Of our ability to deliver a service that people or consumers of the IT service expect. And I kind of liken this with a backpack. You have a backpack, you're supposed to pack the backpack, you pack it up, and then suddenly something else needs to get into the backpack. Now, you can kind of find a way to squeeze it in on top, but if you keep on doing that and you're taking things out from the middle, putting it on top, it becomes an inefficient way of packing a backpack. There's two approaches to this. You can either repack every time you add something, or you can put more pockets in. Historically, what we've done in the network industry, we put lots and lots and lots of pockets in, is now have so many pockets that it's unmanageable. So with automation and through computer-based learning and through analytics, we have the ability to repack that backpack every single time we want to take something in and out, or even when we just want to look at it, and it's invisible to the users. It is a really, really efficient way of solving how do I efficiently use resources in my system. And this is not something you can run on the side, tell a person, and then have the person act upon. This is something you kind of have to interlink with the system more broad itself. And this is what I think is the real exciting part of sort of where SDN and analytics meets the real world. And it's just not compatible with the idea of having lots and lots of pockets of specialized things within that backpack.
And compound that complexity too, Par, with the fact that most enterprises, unfortunately, don't have a really good idea of, don't have a really good view into how the applications are using their network and what that mix is. So, they're in essence packing a backpack without even really knowing what I have to bring on the trip. And that's a very difficult scenario to operate in, especially when you're in a kind of set it and forget it mode in networking. You can't, you keep throwing things on the top of the pack. You can't unload every time you have to add something in. So having that list, having that visibility ahead of time, going in, understanding what needs to be handled by the network and what the loads are associated with that is very, very key.
And then, of course, the ability to say in a bit of time, this is how the size of backpack you need next. This is where you should spend some time and money because this is where things are heading. I think that insight, that sort of planning towards the future, what we at Vello, what we call our application for that, the far side, we think that is really, really important. And this is one of those domains that historically has been done based on averages, and it's really hard to do based on averages.
Just a reminder to the audience, if you have questions you'd like to submit to the panel, please do submit them, and we'll try and make sure there's time at the end. Now, Lee, coming to you and continuing, I suppose, the backpack analogy, even though it's straining a little at the theme, the applications that the enterprise relies upon, and the applications that are traditionally sending data backwards and forwards across the network, do they need to change? Do they need to be learning how to respond to some of this analytics that the network is able to feed back to them? And do they need to have a way to either to ask for more resources if what they're doing is important, or a way to say the thing I'm doing isn't that important actually, so you can bump me to the back of the networking queue or the bottom of the backpack?
Right. I think applications are going to continue to evolve. We're moving to a much more cloud-based and software as a service, self-service application model, and users are going to employ quite a wide range of applications authorized by IT or not. And the key here is linking the application to the network and having some way for the application to understand what the resources it might have available, and also to indicate what level of priority. Does it need a lot of bandwidth? Does it need low latency? Are neither of those critical to the application at a given time? It's that back and forth communication between the application and the network that we don't have today that we need to have going forward.
And are we seeing any examples of that at all at the moment, or is this for the future?
Absolutely. Starting to see examples and SDN technologies that give the programmatic interfaces for the application to tie back to the network, but still very early.
And there's a question come in from Suresh, who asks about how this performance data is actually collected in software-defined networking. He asks, is there an API, or are there actually probes, presumably physically, monitoring flow over the network? Par, how do you do it?
Well, so we actually maintain what we call resource graphs, and we collect data on usage for multiple different metrics, both at the topology level, at the traffic level, and at other levels. We're also working on things like location. We have some of that, and response time applications. So having that sort of set of real-time distributed resource graph is something that we do. I know others don't quite do it the way we do it, but that we think that's actually a really, really important topic, and something that we have introduced and included in how we build networks and support networks.
Okay, good, thank you. And as an organization...
Sorry, if you don't mind, I just realized I didn't completely answer the question. And the second part of the question was, how do you access those counters? How do you access that data? Yes, this is actually a really, really important point. In fact, because we have the ability to span multiple technologies, I mean, there's nothing, an Ethernet looks like nothing like an LTE network or an optical network. Yet we calculate and we have these resource graphs across both. So one of the things that we've done, we have sort of this abstract service model with a consistent set of APIs by which a end user would interact in a uniform way to access these types of data. So yes, the APIs is a really, really important part of that discussion and of that interface. Now, if you don't want to program this directly on your own, then of course what we've done is we built applications that feed that data to higher order systems, and certainly Splunk is one of them, and there are others as well.
What happens? Yeah, carry on. Sorry.
Oh, sorry, Paul. Sorry to interrupt. That's Mark. Yeah, just to add to the last couple of points there, that you'll use a lot of different techniques probably, because there's a lot of sources of very good information, but obviously they've moved in SDN is to centralize control and to bring a lot of that information back into more of a central repository that can be then handled and viewed by any number of systems, because different systems will want different views of all of that information, and there'll be a lot of demands on the network to deliver that information, quite frankly. And from an application standpoint, it's not like every application needs to suddenly be written to make API calls into the central controller of an SDN environment. Is that there's a lot of insulators, if you would, that are at work, and you look at orchestrators like OpenStack with Neutron plugins, and you look at the hypervisors and certainly the virtual systems from folks like Nicira and such. A lot of those go a long way to insulating the application from having to be, in essence, custom built, if you would, or rewritten to take advantage of some of the underlying SDN technologies and to gain access to some of that analytics information.
Good, thank you. So clearly, in a lot of enterprise scenarios, they have control over their internal network. They may well have control over the network that connects branch offices together. But every now and then, things are going to go out beyond their control, onto the public internet or onto leased lines or whatever it may be. How do you integrate those pieces beyond your control into your managed, controlled, visible, analyzed network view of the world? Lee, why don't you try first?
Yeah, I mean, that's clearly a challenge. The wide area network, is sort of the next frontier for SDN. Not only data center to data center, but if you're an organization with tens or hundreds or even thousands of branch locations, how do you tie that back? And these branch locations, folks are going to the public internet, they're going to software as a service applications, they're going back to the data center that has to be reliable, low latency. It's a very interesting challenge.
And Mark, what would you say?
Yeah, I think you're seeing activity on a number of fronts there. And a couple of specific things come to mind that I've been looking at is, you look at the testing systems, and we think of the network testing systems as these are the tools that the vendors use to make sure their networks plug in and operate at certain bandwidth levels and all of those kind of things. But you're seeing, folks like Spirent, for instance, the testing system supplier, creating devices that are very affordable. They're specifically geared towards ease of use, so they don't have all the bells and whistles, but they have the basics so that you're able to plug them into your network very easily and feed information to yourself. So if you do run into issues or you're trying to gain some more visibility into your network. On the cloud front, the cloud is interesting. The cloud, on the one hand, you're trying to release a lot of your responsibility for running your underlying infrastructure and gain some benefits from the economies of scale of a cloud provider. The other thing is you want to be able to still control that cloud and have visibility into that cloud. And there you see companies like Sodexis coming along and offering information to you as someone that's evaluating cloud providers or even evaluating telecom suppliers and trying to understand, okay, once it leaves my building, what kind of a response, what is the load factor when I go out to deliver some information to a remote site, maybe even to a partner, maybe even somebody outside the organization. So you are seeing tools develop that are, again, getting easier to use, providing greater visibility for people that are looking beyond their own infrastructure.
And Par, I mean, are the customers who are coming to you concerned about managing the wide area view of the network, or are they more focused still on what's under their control?
Well, I think what you're mentioning is if I generalize it a little bit more, and I think instrumentation of resources to be able to take a click all the way back into a transaction in a back-end system is a topic that's hot today. And having mechanisms to insert instrumentation at the remote faraway side and across multiple technologies without being dependent on ownership of those technologies is becoming a topic of great interest today. And there's lots and lots of startups in that space. We certainly in the early conversations about how do we extend instrumentations by when it comes into the data center or even at the edge of the data center, how do we make sure that then that instrumentation is used in the best possible way so control can be exerted both at the edge as well as within the data center by having these, let's use the word probes or instruments or some people refer to as virtualized instruments to do those functions. That actually is a really, really important part of getting more data for that analytics side of making active decisions based on prediction. And I think we're really are starting here. And there's been a few false starts in the history before, but this time it looks like it's really real. We see lots and lots of deployments of that, and we've been involved in a few.
And do these probes you're talking about, do they exist throughout the network, or are they effectively on the pieces under your control? So you monitor something as it leaves you, and then you compare it to what arrives at the other end, and there's sort of dragons and darkness in the middle, and you're not quite sure what's going on.
Well, we have some things that, of course, we do, and that's stuff that we can kind of control that's within the domain of our span of control. But then there are companies who basically offers probes that can be instantiated at multiple levels. Then we work with those companies, and it's sort of more of a fact of inserting these probes or these controls or these instrumentation devices, whether it's software or hardware, and at as rich and as many places as possible to create as rich picture of what is going on as possible. So I think we're just in the beginning of it, but you're seeing all the way up in the software stack and the end device, even at things like phones, we're starting to see these types of instrumentation taking place. Clearly, the early start of this is in the high value transactions. You know, the real-time guys have done this for a very, very long time. But it's spreading throughout, and then the sort of performance, SLA, application optimization that spans both the provider houses of providers, service providers, as well as the private data centers, as well as the roaming and distributed users. It's absolutely happening as we speak. And some of these testing companies I was mentioned, they're in the beginnings of that transformation, and others have sort of attached to the brand new ideas. But certainly it's happening.
Good, thank you. Right, we must move along, and I really wanted to explore just for a moment the ways in which the fluidity and the monitorability and shapeability of the network has an impact upon the organization that's using that network. One way to do this is a slide, Mark, that you prepared. Can you just talk a little bit about what this is saying about the network and its impact upon the organization and the way the organization works?
Yeah, I think overall you can see a lot of the things. I mean, we know the value of our networks today. I think the question is that I think we can do better with our networks and deliver along more fronts, and certainly enhance the fronts that we're already delivering on. I mean, we're already providing tremendous. I mean, over the last 20, 30, 40 years, as networks have grown more popular and have grown more standardized and providing greater performance. We've boosted the accessibility and certainly response times. It used to be years ago, I think, it wasn't that long ago, it seemed like 7 seconds was the magic response time number. I think 7 seconds now would be, people would have left already. So from that standpoint, I think that the ante's been raised in terms of, providing the kind of services that the business requires, the end user requires, and even IT in general requires. It's not just about the network being up and running and providing a certain amount of latency or something like that. It's being able to react more quickly, to use more resources, use resources more efficiently. For the service provider, that's a lot about bandwidth, because they over-provision like crazy, and then just hope they get the revenue streams to fulfill their bandwidth requirements. On the enterprise side, it's about using those resources, those servers, those storage devices, even those networking devices, to the point where you're not overbuilding, where you're providing. Geez, I don't want to extend my server more than 30% because I'm afraid it's going to get overloaded. Well, if we want to build that server utilization to a much higher rate, to 80, 90% or so, then we have to have a network that's able to service that and to make sure that that server is active all the time. And certainly from the standpoint of bandwidth and network devices, we spend a lot of money every year enhancing our networks, adding new devices, adding more bandwidth and such, adding more connections. There's only so much you can do, and at some point, even there, over-provisioning translates to much higher costs, and that translates to a direct business bottom line. And with business, it's all about service velocity and value. It's how quickly can you spin some new things up to service your end users, and increasingly your end user is your customer or your partner. It's not just internal workers. So the visibility of the performance of the network, that ante is raised tremendously, because suddenly it's not just your end users that are complaining about slow response times or poor accessibility or the lack of a certain service or something like that. It's suddenly partners or customers, and we know how executives are unhappy.
Yes, and we'll be looking at that in a moment. Good, thank you. Now, this idea that SDN is going to lower your costs, and because it will allow you to more efficiently use the network resources that you have. Is there a danger that we actually get into the situation that the cloud world is finding itself in a bit? This idea of Jevon's paradox, and the easier it is and the more affordable the resources are, the more you use them, so you actually end up spending more money, not less. Mark?
I'm sorry, Paul. Yeah, from a cloud perspective, again, a lot goes to the point that was made earlier about visibility and control. I mean, it's nice to be able to leverage what the cloud is offering you, whether they're whether you're leveraging just basic, web hosting style facilities where you're taking advantage of their servers and their networks and their storage, or whether you're doing something at a higher level and looking at application support from them via like a Salesforce.com, for instance. There still is a requirement to control, and there you still need visibility into how that system is operating. You're still running an IT shop, and you're still operating an IT infrastructure. Just so happens you happen to have a very close partner in a cloud situation. The cloud providers themselves are some of the greatest on the service provider side, are certainly one of the first movers in terms of SDN, because the reality is that they recognize very quickly that they've spent a lot of time and effort and expertise and money on ensuring a very elastic computing infrastructure so that you can, spin up resources very quickly, spin down resources very quickly, bill very accurately, not over provision, so they don't have to spend a lot on their systems. They can take advantage of economies of scale without, again, overspending. So they're saying that, gee, we hooked all of that elastic computing infrastructure to a static network. It really doesn't translate for them. So from that standpoint, they are some of the first movers in SDN. And as Leo alluded to earlier, they in particular, the people that are operating those cloud data centers, are really the first movers in the networking side of the fence that have very tight ties to those new cloud data centers.
Good point, and that leads on very nicely as well. Sorry, carry on.
This part, I think that's a really elegant way of positioning it or articulating the issue. I think we really going back into some things that's been said repeatedly over the last sort of 20-30 years, and I think the discussion is succinct. We are now in a world where we want to emphasize flexibility and malleability, because the response to business changes, and every single business in the world largely is implemented and managed using IT resources. Users are interacting with each other using IT resources and IT systems, whether it's in the private life, in the personal life, or in the corporate life. If efficiency has historically meant picking specialized devices that was tailored for a one type of use, that's kind of given way, instead, where efficiency has become a resource that is reusable and as malleable as possible. SDN is really emphasizing that point. It's de-emphasizing service chaining by device-to-device configuration, instead emphasizing service chaining by system interactions, by how the whole system corporate interact in an as flexible and malleable way as possible. And malleability here is not towards the network itself, but towards how the users wish to interact with the network. I think that is truly the organizational impact. That's the personal leadership impact. And this is kind of where the networking teams is going to realize that they suddenly got a much bigger connection to the interactions with the network versus just shipping bits between point A and point B. And I think that is a personal sort of mental transition that is really important, and it's going to change some of the interactions between business, between IT, and between the end user. So I think that this is a great point, and it is a really important thing to consider if you're a practitioner and expert within this space. You're now suddenly becoming much more system-centric than you ever been in the past. I think that's a very good point.
Good, thank you. I just want to put up one more poll for the audience while we continue the conversation here. And coming to you, Lee, we talked a bit about some of the early adopters of SDN and especially the early adopters of analytic-supported SDN. And I think there was a suggestion a couple of times that maybe the big cloud providers are some of the obvious ones to jump in here quickly. Are they the obvious sort of front runners? And if they are, what does their use case look like? What are the real benefits they're getting very quickly from having adopted an approach like this?
Right. Well, the folks that really rely tremendously on their network and their IT organizations are going to be the first movers of any IT network and SDN technology, and that's the case here. You have some large web-scale companies. Microsoft has been doing some interesting things on its network in terms of monitoring and management with OpenFlow. Google, a lot of the leading telcos really drive their networks hard. So they're looking at they're always looking at how to optimize their network operations. So I think that's where we're seeing the leading edge of the monitoring and management.
Okay, and Mark, would you see sort of the early adopters and the early successes in the same space?
Yeah, exactly. Lee brought up the point of the telco providers and service providers themselves. It's funny, we think of them as, well, they're the folks that have all the bandwidth and have all the connections, and yet it's also it's the biggest part of their cost equation. And they, how do they survive? Well, they over provision and they operate their lines typically at 30–40% utilization, maybe peaks of 50–60, but that scares them once things get beyond 50 or 60. And we're talking about some of the early trials and early uses of SDN being focused on, again, provisioning bandwidth more efficiently and being able to use those lines without fear of suddenly overstepping your bounds and going beyond and basically bringing the line down or bringing things to a halt, and being able to bring in more bandwidth more in a dynamic fashion. And there you're seeing telcos moving to the 80–90% level in terms of utilization, and then having spares off to the side. So it's controlling an extremely costly resource for them. On the enterprise side, it tends to be less about bandwidth and more about operating expense and focusing in on easing the burden on their staff, and again providing for more dynamics within the network. And again, there you're saving a lot of time in terms of support staff and the kind of systems that you need to put in place and practices you need to put in place to make sure your network is up and running. So therefore, having analytics mixed into this more automated SDN environment certainly allows for people to get further away from having to worry minute to minute on how their network is performing, and then get focused more on, again, making their network better as opposed to just keeping it running.
And looking at the poll results here, it would suggest that people on the webinar, at least, are keeping quite a close eye on their logs. I must admit that personally I'm surprised that the first one scores as low as it does. But Lee, does this look realistic? Does this look representative to you?
I think that's representative. The CEO, users are going to call when there's a problem. I think most network pros, try to be proactive and monitor and manage their networks to the best of their abilities.
Yeah, I'd probably love to hear the definition of regularly, and obviously there's an association of time spent there as well. I'm sure there are some regular analysis of the logs. Some are more complete than others, depending on how busy that day or that week is or something. So the whole point is that you can actually get away from doing most of that work And also, you can, having systems do it, you're doing it on a more real-time basis as opposed to every week or every couple of weeks or every month, as some of the people had said. Again, that's the whole point.
Yeah, yes, absolutely. Good. We are almost out of time here, so I just very quickly want to look at the final bullet point on this slide and then try and rattle through some of the questions that the audience have sent in. So looking at the people who've successfully implemented, and we've talked about some of those, telcos, cloud providers, and the like, what lessons can they teach us about the big pitfalls to watch out for? What are the mistakes we want to learn not to make again? And Par, presumably you're seeing a lot of this, so over to you first.
Sure. I think that one of the things that we've learned as a company is together with our customers, of course, is that pick your starting point. Pick the place where you believe, and when you through analysis or some other mechanism have decided that this is where I can derive maximum amount of business value from an SDN approach. We found in most of our engagement that sitting at the edge of the data center and interacting with some of the higher cost resources, particularly the things that enters and leaves the data centers, or one of the particular workloads that is particularly sensitive to how networks interact with each other, picking that as the starting point has been very, very successful for us. Many of the service providers that the problems that we talked about earlier in the previous slide about around service providers have challenges with the cost of the network. It's typically not something that they can charge the end user. They can charge for the speed of the connectivity, but ultimately what happens is there's a very, very small group of the subscribers that use a very, very large amount of the network, and then when they sort of pass them on the bill or try to do something about it, it's always reactive, and it's always in a more negative sense. If they instead can offer that as a self-service programmable interface where the end user can kind of select how they wish the network to behave, and perhaps couple that to costs or to SLAs or to something else that's meaningful to the end user, those customers have been more successful. And in some markets, bandwidth is something that you cannot provide on your own. You have to get it from someone else. Particularly in the international sector, we have bandwidth provided by, in some countries, nationalized organizations, telcos, and they are typically very, very expensive, and you cannot offer them on your own. Having the ability to select that and select that based on end user priorities is a powerful starting point. The ability to set up cross data center systems that allows changes to happen with application of one data center automatically reflect back into the other through the network, and the network self-configuring for these changes. We've built now a number of applications with storage products like replication and active storage from the leading vendors, EMC, IBM, and others. And we found that to be great starting points. And then as our users get more comfortable with it, they start deploying it more. Now, there will also be the ones who are much, much farther ahead intellectually with this, and they go straight for the heart. They go straight for the core of the data center. But my experience is, if you're starting out, start at the edge and do something there that is the most business aligned while you learn how to interact with the system differently than what you ever done before.
Okay, good, thank you. Now, Lee, just briefly from you, one pitfall that people can learn not to make because someone's done it already.
Right. Well, what I look at in this challenge is, focus on OpEx. OpEx is in the people operational expense. Your people is your biggest expense. It's going to be 80%. And don't worry so much about the specific cost of a bit, but how are you going to make your organization and your people more efficient?
Okay, good. Thank you. That was short and to the point. Wonderful. So we have about 60 seconds or so to rattle through some questions. Let me see. We had a question from Frank Greco who asked, talking about the APIs that are monitoring the network within an SDN. He asks whether they're real-time APIs or whether you have to use something like REST to poll for the data. Par, how do you do it?
So we have, I mean, we have the ability to build APIs as we wish. The APIs that we use currently are RESTful. We have also other type of APIs that you can more directly interact with the system with. And more importantly, we can actually run a part of your own homegrown application that you want to monitor something with inside of our control plane directly. So we're pretty rich in our flexibility for how you interact with our system. You don't necessarily have to sit outside of it and do this fully RESTful. I think it just comes down to the use and how you wish to interact with it and how you wish to see the data. There's always a trade-off between how much cost it is to generate the metadata about the data, but we're fairly flexible and our system keeps on evolving. I should tell you, for those who want to know more about sort of the package that we've done with Splunk, and I just want to make sure I say that before we run out of time, we set up a URL on vellosystems.com/Splunk where people can kind of read more about what we've done there and perhaps a little bit more about what's coming next.
Good, thank you. And let's just take one more question, and I'll give this one to Mark. And Vincenzo asks, what's the impact in terms of cost to upgrade an existing legacy network to benefit from SDN? Is this a doubling of your cost, a quadrupling of your cost, or does it all just come for free?
I guess the sensible answer would be to say that somewhere in the middle there. You're certainly you have to take a look at yourself. You have to inventory your hardware. You have to inventory your software. See where you are. Some devices go through very smoothly. Some with the latest device operating system upgrade gain, say, OpenFlow capabilities and things like that. But there's undoubtedly going to be some devices that even though they may become OpenFlow dependent, they may also not respond to the kind of say in the analytics requires its own level of interaction and a very high degree of interaction with the centralized controller and the net devices themselves. So you have to understand where your devices are and how ready they are. How do they upgrade? The networking device vendors are very good at providing information about that. Some are more aggressive than others about OpenFlow compatibility, but again, that obviously impacts your cost. The controllers themselves are being offered very reasonably, tend to be a pretty not insignificant licensing charge, but a relatively insignificant. Some vendors don't view the controller as being something that they're even looking at a lot of value in or making a lot of money from. So to them, it's about providing you a chassis, and then they'll make money on providing all the options that go on top of the chassis, like applications and such. The ecosystems are very important to judge in terms of matching up your ecosystem, the applications you use. How does that match up against the SDN vendor's ecosystem? Looking at those things. And obviously, a good match there lessens your development costs, lessens your tuning costs. So you're looking for a good match to your environment. And those are ways of managing the costs associated with it. Don't look anytime too soon. And my belief is for the white box router or the white box switch, and suddenly you're buying generic hardware to inside of your network. Network devices tend to be fairly specialized. I think there's some opportunity to move network functionality into the server, and again, gain some benefits there by lessening the drain on networking devices, allowing you to buy cheaper networking devices in the future. But in terms of specialized network devices, I think they continue on. And you look at things like analytics that put a particular drain on network devices in terms of gathering the information without affecting traffic management, and then also feeding information up to a controller on a real-time basis. That's a very demanding application, one that's fairly specialized. So those are the places where network devices will retain some specialization versus a traditional, again, white box server with a few network interface cards in it.
Good, thank you. And I'm afraid we're over time. So Mark, Lee, and Par, thank you very much for your time. And to all of you in the audience, thank you for your attention and for your questions. I'm afraid we didn't get to as many of them as we would have liked, but thank you very much for your time, and I hope to see you on our next GigaOM webinar soon. Goodbye.